Okay guys, this is CAP 27 and this is the problem with the block and like anything. It can be a cube that is submerged in a fluid. In this case, our block is 25% submerged in the fluid. Our fluid is water and water's density is 1000 kilograms per meter cubed. And the density of the block is 0.5 kilograms per meter cubed. And the volume is 30 meter cube. Our height is 5 meters here. The width and length, they're not important, they'll be given. We'll use the height later in the problem. So the first question is about tension. What is this tension in this string? To find tension, we will say that the tension is in y direction. So most of the forces are in y direction in this problem. So the forces in y direction are in equilibrium. Nothing is moving, that's why it's equal to 0. And when we add all the forces in y direction, we should get 0. What are the forces in y direction? One is buoyancy force. That is the force that is pushing this block up. There's tension force, that's what we need to find, this tension. And then there is the force of gravity. So buoyancy force, it is equal to density of the fluid, not the density of the block, it's density of the fluid times gravity times the volume submerged plus force of tension. And then buoyancy is upward force, that's why it's positive. And then the gravity is in the negative, so it's like negative mass times g. That's the gravitational force. So, but what is the mass? Mass is not given, but we can find this mass. So the density equals mass over volume. So to find this mass, we can multiply the density of the block by its volume. That's what's written here, the density of the block and then the volume of the block. So the density of the block is 0.5 and then the volume of the block is 30 meters cubed times g. That will give us the gravitational force. And so the buoyancy force is the density of the fluid is 1000 times 9.8 times volume submerged. So the total volume is 30, right? And then the volume submerged, it's 25% of the block is submerged, so we would multiply that by 0.25 to find the volume submerged. So the 25% of the 30 meter cubed volume is submerged, and 1/4 of the block. So this would give us 73,500 plus, so what I did is I rearranged. So since we need to find the force of tension, I transferred the buoyancy force to the other side of the equation, so that's why it has negative sign. And I transferred this gravitational force to the other side, so that's why the minus sign got positive sign. So this is the tension force of the string here. So the next question is to find the pressure at the top of the block and at the bottom of the block here. So the top of the block, since there's no fluid, it has only atmospheric pressure, so atmosphere is pushing on the block. So we know the atmospheric pressure, it will be given, or probably you should remember this number. That doesn't change. So pressure of the atmosphere is this. So the pressure at the top is this. What about the pressure on the bottom? Pressure on the bottom, you would add the atmospheric pressure plus the pressure of the fluid. Atmospheric pressure is given. Pressure of the fluid is equal to density of the fluid times gravity times height. Height in this case is depth. So this is the depth. what I mean is like the height starting from the top of this fluid till this point. What is the height, like this part? If he could have asked you the pressure like at point, for example here, then you would have to find, I mean probably it will be given the height, I mean the depth starting from the top to here. I hope it makes sense. So you don't take the height from the bottom, but you need to start counting from the top. So here we're asked to find the pressure here at the bottom. So we need to find what would be this height. So what is that height? Since this is like 25% submerged, so that if our height is like 5, then what would be the 25% of that height? So you would multiply 5 by 0.25. That would give you the height submerged. And you'll get the pressure at the bottom if you add the atmospheric pressure plus the pressure of the fluid.